In this lesson, we're going to study how to incorporate time into our decision models. We're going to do this in the context of a production planning model. Production planning is a classic problem in manufacturing that seeks to address how to optimize a production schedule given capacity constraints, inventory costs, and seasonal demand patterns. In the current problem, we're given demands for a number of periods. In this particular instance, we're given 12 numbers, one for each month, that correspond to the number of units that we need to deliver in each month. All of the numbers are in the millions of units that we need to deliver. As most products in retail, demand for this product has seasonal effects, with demand varying from month to month. Your task is to decide how many units you produce in each month of the year. If you produce units during regular hours, your cost per unit is $10. Your production facility is capable of delivering up to 50 million units per month using only regular hours. You can also go into overtime, but units produced during overtime are more expensive. They cost $12.50 per unit. In any given month, you can produce up to 25 million units in overtime. If your demand in a given month is higher than 50 million, you have two options to satisfy the demand. You can either go into overtime, or you can satisfy the demand by accumulating an inventory of units in advance. If you choose to build an inventory, you need to pay an inventory holding cost of $1 per unit per month. The inventory holding cost is a way to account for several costs, including the cost of real estate necessary to keep those units, the security costs associated with holding the units, and the financing cost of the raw materials. Assume it is now January 1st, and you want to build a production schedule for the year. You currently hold 10 million units in inventory, for which you can assume that the holding cost was already paid for in the last month. How many units should you produce per month to satisfy your demand? Please go ahead and try to build a linear optimization model to solve this problem.